Hey, this video is going to help us review for Module 2. So we're taking a test tomorrow, so we want to make sure that you do the review now and practice with me so that we can clear up any questions. And then if you do have any questions when you finish, be sure to email your teacher and let them know what else they can help you with before the test. So we're going to start here on number 1, but before we do number 1, we're going to do a practice problem together. So you're going to need paper and a pencil as you're watching this. So we're going to do a practice problem together. You'll pause the video, come back and do number 1. We'll do a practice problem together. You'll come back and do number 2. So let's head to our first practice problem. So if you don't have paper and pencil, go grab them now. So we're going to start here. Hey, so we want to know what vocabulary word is being shown here. So we started with the numbers 6 and 8. So then I can see 6, 12, 18, 24. So, they're making a list of 6s. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 times 4, and so on. 8 times 1, 8 times 2 is 16, 8 times 3 is 24. And they made a list of 8s. So they multiplied to make this list. And then I see here they've circled 24. So that is the smallest number that they have in common. So what has happened here is they have found the least common multiple. So I want you to see if you can think of a definition for least common multiple. So the least common multiple is the smallest number that they share when you multiply. 6 times 1, 6 times 2, 6 times 3. So remember, multiples are more. So go ahead and pause the video and complete number 1. Come back when you're ready for number 2. Okay, so now it wants to know what these are examples of. 4, -7, 19, 38, 43. So these are all whole numbers or their opposites, positives and negative whole numbers. Those are integers. So then we have 3/4, -5/10, 6, -3 and 7/10, and -1/3. So I see here that we have several different types of fractions. And now you might be wondering why I said fractions when some of these are decimals or whole numbers, but I can turn, I know this is 50 out of 100 is a half. I know this is -1/2. I can make 6 over, put it over 1. 6 divided by 1 is 6 to make that a fraction. And over here, I have -3 and 7/10 to make that fraction there. So decimals, whole numbers, and fractions are all considered fractions, and we call these rational numbers. So rational numbers are expressed as fractions. So see if you can write the fraction 4 out of 5. So let's check that. 4/5 is a fraction. See if you can write -6/10 as a fraction. So -6 out of 10. I can also simplify that and divide the numerator and the denominator by 2 to get -3/5. And see if you can write 9 as a fraction. So remember, 9 will go over 1. 9 divided by 1 equals 9. But 9 over 1 is a fraction. So all of those are examples of rational numbers. So go ahead and pause the video and complete number 2. Okay, number 3, we're going to write an inequality to compare. So comparing symbols are our greater than and less than signs. So we have 4/6 here and 5/8. Be sure to write those down with me. Now we do not have common denominators and we don't have common numerators. So we want to make them have something in common. So I'm going to make a list of sixes. So 6, 12, 18, 24, 30. I'm going to start making my list of eights. We don't have 8 over here. No 16, 8, 16, 24. Oh, but we do have 24. So I can use that least common multiple as my least common denominator as well. They are the same thing. So I'm making my new fractions. So think 6 times what is 24? 6 times 4, and I have to do the same thing to the top. 4 times 4 is 16. 8 to get to 24 is 1, 2, 3 times. You have these lists over here that can help you. And then 5 times 3 is 15. So now I can compare that 16 pieces out of 24 is greater than 15 out of 24. So that means 4/6 is greater than 5/8. So when we're comparing fractions, we want to make common denominators with our least common multiple. See how many times the denominator went into the numerator. Do the same thing to the numerator. So go ahead and pause the video and try number 3. Hey, now we're again being asked what vocabulary word is being represented here. So we've got 24 and 18. 1 times 24, 2 times 12, 3 times 8, 4 times 6, all equal 24. 1 times 18, 2 times 9, 3 times 6, all equal 18. Then I notice the number 6 is circled. They don't have 24 in common or 12 or 8. The first one is 6. So these are the greatest common factor. So the greatest common factor is the largest number that they share. And remember, factors are fewer. Factors are when we list the numbers that you can multiply to equal the other. Factors are fewer. So go ahead and pause the video and complete number 4. Number 5, we have a fish that was 3.4 meters below sea level. So negative 3.4. A bird was flying at the same absolute value in the sky. What value would represent where the bird is? So here's my C at 0. I know my fish was down here at negative 3.4. And then it says I have a bird that's the same absolute value. So this distance and this distance are the same. So the absolute value of negative 3.4 is 3.4. So that means this bird is the same absolute value up in the sky. So its value is 3.4. Let's go ahead and pause the video and try number 5. All right, we're going to order these from least to greatest, but I notice they do not have a common denominator. So I'm going to list out 3s. So 3, 6, 9, 12, 15. I'm going to list out 4s. 4, 8, 12, 16, 20, and some 6s. 6, 12, 18, 24, 30. So I'm looking for the smallest one they have in common. So they do not all have a 3. I see 6 here and here, but no 6 in the 4, so it's not 6. I don't see 9 on any other list. 12, 12, 12. It looks like our least common multiple for 3, 4, and 6 is 12. So I want to rewrite new equivalent fractions. So be sure to do this with me. So think, how do we get from 3 to 12? Times by 1, 2, 3, 4. So we're going to do 2 times 4 is 8. 4 to 12 is 1, 2, 3 times. 1 times 3 is 3. And 6 to 12 is 1, 2 times. 2 times 3 is 6. So now we have the same denominator. They're all cut into 12 pieces. So I'm looking for the smallest one is here at 1/4. So I can see these are matched up. And then next is 6, which is 3/6. And then last we have 8/12, which is 2/3. So we always want to put them back in their original form here unless it asks otherwise. So go ahead and pause the video and try number 6. Okay, we have a number line here. So first we're going to look and see what is each whole cut into. So I can see here's 0, here's 1. 1, 2, 3, 4, 5 pieces. That means every unit here is standing for a fifth. So first we're going to locate each star. So here's A is 1 whole unit and 1/5 more. So negative 1 1/5. B is over 1, 2 out of 5 places. So negative 2 out of 5. C is towards the positive side, 1, 2 places. Oh, I noticed that B and C are actually opposites of each other. And D is 1 whole place and 1, 2, 3 out of 5 places over. Now we're going to tell their opposites. So the opposite of 1 1/5 would negative 1 1/5 would be positive 1 1/5. The opposite of negative 2/5 is positive 2/5. Sorry about that silly 2 there. The opposite of positive 2/5 is negative 2/5. And the opposite of positive 1 3/5 is negative 1 3/5. And now we're going to record their absolute value, so their distance to 0. So to get from A to 0 would take 1 1/5 move. And remember, the distance is always going to be positive here. So to get to B, it would take 1 2/5, always positive. To get to C, it would take 1. Oh, I'm sorry. I've been doing C wrong. Here's 0. I've been counting it from the wrong place. You guys are probably wondering what I'm talking about here. So C is just 1/5 over. I'm really sorry about that. And C here, the opposite is negative 1/5. That sounds better. So they are not opposites. B and C are not opposites. Okay, to get from 0 to C takes 1/5. And to get from 0 to D takes 1 3/5 move. So notice all of the absolute values are positive on that. So go ahead and pause and complete number 7. Make sure to read the directions. Okay, number 8 asks which inequalities are correct. So we need to look through all of them to see. So here we have 36 hundredths, like 36 cents. And this one we have 3/6. I know that I can divide 3 and 6 by 3. A common factor is 3. 3 divided by 3 is 1, and 6 divided by 3 is 2. So when I have half of $1, I know that equals 50 cents. 50 cents is greater than 36. So this one is true. Hey, we have 4/5 and 0.75. So let's take our fraction here and turn it into a decimal. So we have 4/5. So it's nice to turn it into 10 when we can, because decimals are in tenths. 5 to 10 is 2 times. So 4 times 2 is 8. 8 tenths is 8 tenths. Well, I want to remember to put that extra 0 there. 80 compared to 75. If I just think 8, I might think that 8/10 is smaller, but 8/10 is actually greater than 75 cents. So this one is also true. Hey, now we have 2 1/3 and 2.33, 2 33/3. So the fraction 1/3 is the same thing as 0.33. That's a nice benchmark fraction to know. So 2.33 is the same as 2.33. So these ones are actually equal. So this one is not correct. Okay, our last one here, we have 5.2, so 5 2/10. They said it is less than 5 1/2. So for 5 1/4. So I can do a couple things here. So I'm going to turn this into a decimal. 1/4, whenever I hear the 4 as a denominator, think quarters. So 5 1/4 is 25 cents. And I also want to add that 0 here to make it easier to compare. So $5.20, $5.25, $5.25 is greater. That one is also true. So go ahead and pause, and you can turn decimals into fractions. You can turn fractions into decimals. Either way you want to work, but some way you need to prove and compare them. Don't just guess. Prove it by turning either a decimal to a fraction or a fraction to a decimal. So pause and do number 8. Okay, number 9, we are going to compare these inequalities this time. So here we have the absolute value of -4/10. So that means it takes 4/10 to get from -4/10 to 0. And absolute value is always ending up positive here. So we have 4/10 compared to -4/10. I know when something's positive, it's going to be farther to the right. So positive numbers are bigger. So even though it was a negative value, I want the absolute value, which is the distance, and the distance is greater than the value. Hey, let's come down here. So we have -6/10, -3/4. So remember 4, when I see 4 as a denominator, I think quarters. 3/4, 25, 50, 75 cents. So -0.75. I'm going to add the 0 here so they each have 2 places into the hundreds. -60 cents, -75. So thinking negatives, if I'm on my number line, draw your number line if you need to. Here's 0. If I'm going over, here's -1 cent, 2 cents, 3. So -10 cents, 20, 30, 40, 50, -60 cents, and -75 would be even farther to the left. So that means -60 cents is greater than -75. So because they're negatives, everything is opposite. So if we're talking positive, 75 is bigger. But when we do the opposite, we have to flip the sign as well. Okay, let's come down here. So we've got -4/5, but it's the absolute value. So the absolute value of 4/5 is 4/5. And we've got 0.75 or 75 hundredths. So I'm going to turn this here into a tenth. So 5 to 10 is times by 2. 4 times 2 is 8. 8/10 is 0.08. And add that 0 to be able to compare it better. So we've got 80 cents and 75 cents. 80 cents is greater. So even though this was a negative value, it asked for the absolute value, which is the distance. Okay, our last one here. So a little trickier. So let's see if we can think about this. So let's start here inside our absolute value, -2/5. So, but it's the absolute value, and I know value is positive. So to get From negative 2/5 to 0 is 2/5. But now it wants us to make it the opposite. So the opposite of 2/5 is negative 2/5. Compared to negative 2/5, they are equal. So this one could become negative because this was outside of the absolute value. This means the opposite of negative 0.25 absolute value is 2.5. Opposite is negative. So they ended up actually being equal. Okay, go ahead and you're going to pause and do 9, 10, and 11 are all similar to these. So make sure you change one, either fractions to decimals or decimals to fractions. Make sure you have proof and not just a guess. Okay, number 12, we have a parking lot to go to a cave that is located at 5.6 meters above sea level. So we've got the parking lot up here, sea level's here. So here's 0. Parking lot is 5.6. Here's my nice little car in the parking lot, 5.6. The stairs from the parking lot are at the opposite location. So here's the start of the stairs at 5.6. The opposite location from the cave entrance. So down here, we've got the cave entrance is opposite of 5.6. So what rational number would represent where the cave entrance is? So the opposite of 5.6 is negative 5.6. So go ahead and try number 12. Hey, 13 asks us to use the distributive property to show the sum of 12 and 8 as the product of the greatest common factor. So I know this is kind of wordy, but I'm going to pick out words I know. Greatest common factor when I'm adding. So I need to multiply and add with my greatest common factor. So first we're going to start and find the greatest common factor of 12 and 8. So 12 is 1 times 12, 2 times 6, 3 times 4 are the factors to make 12. To make 8, we have 1 times 8, 2 times 4, 3 can't go in there, and we already have 4. So the largest factor they have in common is a 4. So I'm going to pull that factor out. And I ask myself, 4 times what is 12? 4 times 3 is 12. And then I'm going to add on the other one. So I need my 4 that I pulled out. 4 times what is 8? 4 times 2 is 8. So now I'm going to combine my 4. I'm going to combine what's in my parentheses by adding them. So 4 times 3 plus 2 is 5 is how I would use the distributive property. 4 times 5 is 20. So when I have 12 objects and 8 objects, 12 plus 8 is 20. I would pull out 4 of everything and have 5 groups. So you pull out the greatest common factor, tell me the other one. So look, 3 and 4, here's 3 and 4, 4 and 2, here's 4 and 2. Put the other ones together here. Let's try another one of those. So this time we have 42. So 1 times 42, 2 times, I know it's even, so 21. 3 times, oh, I don't know that one off the top of my head, so I'm going to do a division problem. So 3 goes into 4 one time. 1 times 3 is 3. So there's 12 left over, 4, 14. So 3 and 14. 4 can't, 5 can't, 6 can, 6 and 7. And I'm done there. I'm going to get this out of the way here. And now we're going to do the factors of 54. Remember, factors are fewer. 1 times 54. 2 and 20. Oh, man. It's It's been a long day, and I think I just need to do that one. So it goes in there 2 times. There's 4, 14, 27. Okay. Oh, that makes sense because 7 doubled will end in 4, 14. Okay, I know 5 plus 4 is 9, and 3 goes into 9, so it looks like I've got another problem to do. So 3 goes into, when I add the numbers together, 3 goes into 54. So it goes in there 1 time with 2 left over, brings down the 4, goes in there 18 times. So 3 and 18. 4, oh man, I better check just to be safe. So that goes in there 1 time, 1 left over. Oh, 4 can't go into 14 even, so not 4. I know 5 can't because it doesn't end in 5 or 0. Oh, 6 can. 6 times 9. 7 can't. 8 can't. I already have 9. So now we're going to look for our greatest common factor here. Those dots out of the way. So they do not both have 54 or 27 or 18 or 9. Oh, but they do have 6 in common. So I'm going to pull out the 6. 6 times 7 is 42. And I'm going to add on, oh, I forgot my 6 here. Oh, took it all away when I undid that. So pull out my 6 again. 6 times 9 is 54. So I match up my 6. And I'm going to add what's in the parentheses, 7 plus 9. And to finish, 6 times 16 would be my final answer here. Okay, so go ahead and try number 13. So just follow the same steps here. List the factors, then put your greatest common factor out here to the side. Then I asked myself, 6 times what is 42? That answer was 7. 6 times what is 54? That answer was 9. Put your adding parts together and combine them to finish. Let's go ahead and pause and do number 13. Okay, last one here for the day. We've got the weight of pygmy owls listed below. So a Eurasian owl is 2.8 ounces. The mountain owl is 2 3/4 ounces. The East Brazilian one is 2 3/5, and the Andean is 2 64/100. So we want these from least to greatest. So I'm going to make my fractions into decimals. Oh, I love when I see 4 as my denominator. I think quarters. So 2 wholes and 3/4 is 75. Okay, I'm going to write this one over here and line it up 2.8. Okay, here we have 2 3/5. So I'm going to make that into 10. 10 is always our decimal number if we can. 5 to 10 is times 2. So 3 times 2 is 6. So 6/10. And I have 2 64/100. Now, so I don't get confused and think that 6 and 8 are smaller, I'm going to add these placeholder zeros to make them all have a whole number, a tens place, and a hundredths place. Even if there's nothing in the hundredths place, I want that placeholder to hold that place. So now I can kind of think of it like money, which is the least amount of money, $2.60. So 2 3/5. The East Brazilian owl is the least. So that one's done. Next is 2.64, which was the Andean owl. And then we have 2.75 or 2 3/4 for the mountain owl. So last left us with 2.8. So I know 0.8 sounds smaller than 64. But when we add that placeholder 0, remember it's really 2.80. So 2.8 is the greatest. Okay, so go ahead and try number 14. And then if you have any questions and you are stuck, please let your teacher know so that they can help you before you take the test tomorrow.